The basics of suspension setup are covered in the owner's manual and the master repair manual. We recommend you always have these on hand at all times. A decal outlining these production settings and recommended spring rates for different rider weight is located on the clutch cover of each snowmobile or on the underside of the hood. These decals provide a guideline to be used for initial suspension setup. It's best to start with the spring recommended for a rider's weight as listed on the decal, and then make small changes as required to tailor fit the ride to your customer. The first and most important thing you should always do before beginning any type of tuning is to inspect the machine and make sure that all parts are in good working order and properly lubricated. Like all Polaris premium lubricants and maintenance products, all-season grease was specifically formulated for use in all riding conditions and temperatures. Be sure to remove the weight from the sled first to allow grease to penetrate the load-bearing areas of pivot shafts and bushings. Inadequate lubrication or using the wrong type of grease is one of the most common causes of ride quality complaints. Always refer to the Master Repair Manual for all lubrication fittings. Inspect the condition of all suspension components and replace any worn or damaged parts. Be sure all fasteners are in place and tighten securely to the torque value listed in the snowmobile repair manual. Inspect the Hifax and track clips for excessive wear. It is important to check both the clips and the Hifax at the same time. Since they work together, damage could be done if one or the other is in poor condition. Begin by measuring the distance between the Hifax and the rail at several points along the rail. When any Hifax is worn beyond specification, it should be replaced. The wear pattern on the Xtra 12 is somewhat different than the Xtra 10 or Xtra Light. The rear portion will wear rapidly at first, but after the initial break-in, the wear will cease. Replacement of Hifax is similar on all models. Install the new Hifax, which should be at room temperature, by sliding it in from the rear of the rail. Because the Hifax need lubrication to operate properly, new Hifax are best used in deeper snow conditions. Worn or broken in Hifax are better used in rough, hard pack conditions. If necessary, remove and replace worn track clips using the track clip removal tool, part number 2871337. Position the tool jaws on the edge of the clip and squeeze the handles together to remove the clip. Using the track clip replacement tool, part number 2871041, install a new clip. Position the clip in the proper place on the track, being careful not to damage the track rods, which are inside the track. Position the installation tool on top of the clip and squeeze the handles together to crimp the new clip. Track adjustment and alignment are also critical to the servicing of the snowmobile suspension. In order to maintain proper alignment and tension, support the rear of the sled off the floor and run the machine so the track turns freely. Looking through the track window, make sure the rails are evenly spaced on each side. Tighten or loosen the adjustment bolts until the track is evenly aligned and adjust the tension. Refer to the track tension specifications in the Snowmobile Master Repair Manual. A loose track can cause abnormal operating noise, vibration, or even track damage. A track that is adjusted too tight will reduce usable horsepower, accelerate Hifax wear, and change the ride characteristics of the suspension. It may also cause a vibration or damage the track and suspension. Steering alignment is very important to the overall feel and comfort of a snowmobile. Always perform a detailed inspection of the front suspension and steering components as outlined in the Snowmobile Service Manual. Begin by recording the particular steering alignment specifications noted in the Service Manual because the measurements are different for each model. Referring to the notes at the bottom of the chart, you will see that camber and maximum width measurements are taken with the front end elevated and the shocks installed. We will begin with the Xtra 12 camber adjustment by supporting the front end and removing the skis. Now, perform a couple of preliminary checks. Measure from a common center point on the sled to the center of the ski spindle tube on the trailing arm. Be sure to measure to the same point on each side. The grease fitting is not always located in the exact center of the tube, so be aware of this when taking your measurements. This measurement should be within 1/8 of an inch. An adjustment is usually not required unless parts have been replaced. If the difference is greater than 1/8 inch, make a note of which side is longer. Measure the maximum width setup specified in the Master Repair Manual and record it for later reference. Now check the camber. Remove and inspect the ski pivot bushings and slide the alignment bar through one spindle toward the other spindle. It should slide all the way through both spindles if camber is set properly. If adjustment is necessary, remove the bolt from the lower radius rod, then loosen the jam nut on the rod end and adjust the camber by lengthening or shortening the lower radius rod. Replace and retorque all fasteners according to the master repair manual. Recheck the camber using the alignment bar. If adjustment is correct, the bar will slide through both spindles. Measure the width again to be sure it is still less than the maximum width listed for the model. If the measurement exceeds the specifications, the torsion bar could come loose and interfere with steering. If it's too wide, both upper and lower radius rods must be shortened equally to maintain the correct camber adjustment and narrow the front end. For models equipped with Xtra 10 or XC10 CRC style front suspension, adjust the camber by first removing the ski bolt pivot bushings and slide the alignment bar through one spindle toward the other. Camber measurement is taken from the top of the alignment bar to the top of the ski mount hole on the inside of the spindle. Record this measurement. Then slide the bar through the other way to check camber on the other trailing arm. Compare the measured camber to the specifications of the model you are working on in the master repair manual. To make an adjustment, rotate the radius rod as we did on the Xtra 12 as many times as necessary until the correct camber measurement has been reached. Install the trailing arm bolt and verify that the camber is now within specs. Now check width measurement to make sure it does not exceed the width specification. Ski toe adjustment is performed with the sled at ride height. Begin by inspecting the steering linkage for any worn or damaged parts. First, make sure the handlebars are centered. On units with zero camber, such as the Xtra 12, slide the alignment bar through the spindles and adjust the drag link to center handlebars. Check handlebar center by measuring from rear of tunnel to handlebars equally on both sides. On models with negative camber, the pitman and idler arm should be pointed straight forward. Now lay a straight edge against the track. Measure 10 inches in front of the spindle and 10 inches from the rear of the spindle. The distance from the center line of the ski to the straight edge should be within 1/8 inch toe out. If adjustment is necessary, loosen the tie rod jam nuts and turn the tie rod to achieve correct toe measurement. Now check the other side in the same way. Total toe out should be 1/8 to 1/4 inch toe out. Make sure to tighten both tie rod jam nuts and be certain that both inner and outer tie rods are parallel to their mating surface. Once you have set the sled to proper specifications, it is time to make some adjustments. To better understand the available adjustments and the effect each has on ride and handling, consider these three adjustable points: the IFS shocks, the front torque arm, and the rear torque arm. Each point supports a given amount of weight, and changes made to one point have an effect on the other two. The key to suspension tuning is to determine what must be changed to obtain the desired ride and handling characteristics. Spring rate is one of the most important factors in a properly tuned suspension. There are two types of springs used in Polaris suspensions: coil springs and torsion springs. Spring preload has a large effect on ride performance and can be adjusted on all types of suspensions. Preload is the amount of pressure at which the spring is held. On a coil spring, the longer the installed length of the spring, the less amount of preload or the softer ride. The shorter the spring, the more preload or the stiffer the ride. The different types of coil spring preload adjusters are the threaded adjuster, the cam style adjuster, and the snap ring style, which is used mainly on Fox shocks. To increase preload, turn threaded adjusters clockwise as viewed from the adjuster end of the shock, making sure there is at least 2 threads showing above the nut. Turn the cam style adjusters to a higher setting, or change the snap ring to a higher position on the shock. On models not equipped with any of these adjusters, shims may be added to the bottom of the springs for added preload. Adjusting the spring preload will help maintain the correct sag of the snowmobile. In the rear suspension, measured at the rear bumper, there should be 1.5 to 3 inches of loaded sag depending on rider preference. In order to get an accurate reading, the sled should be set to full riding weight with all fuel, oil, and coolant levels correct. First, have the rider sit on the sled and measure the distance from the ground to the rear bumper. Then have the rider get off the machine and check the measurement again. Adjust the spring preload to achieve the 1.5 to 3 inch sag dimension. On the Xtra 10, if adjustment is necessary, you will first turn the torsion spring adjuster cam until the proper sag has been achieved. On the Xtra 12, you would first make the adjustment to the front track shock spring. If you cannot achieve the proper sag, then return the spring to the original position and then adjust the torsion spring cams. The front suspension should sag 1 inch under its own weight measured at the front bumper. In order to achieve the proper amount of front suspension sag, increase or decrease front spring preload. To increase the spring preload, turn the shock spring clockwise, or counterclockwise to decrease preload. Stiffer or softer springs may be installed as needed to keep the sled from bottoming. The production setup will most often deliver excellent ride and performance for a given set of conditions. However, suspension adjustments involve a compromise or trade-off. A machine set up to perform well for an aggressive rider in the moguls will not suit the preference of a trail rider on flat groomed trails, and preferred setups will often vary between individuals. Some adjustments, like the IFS spring preload, rear torsion spring preload, limiter straps, and scissor stops, may be adjusted to suit various riding conditions and rider preference. A shock absorber has to perform 2 basic functions. It must dampen the force of a bump on the compression, or jounce stroke, and prevent the suspension from springing back too quickly on the rebound stroke. If the compression damping is correct for conditions, the shock absorber will dissipate the force of a bump before the suspension travel is used up. If the damping is too light, the rider may experience frequent bottoming. The Indy Select and Ride AFX shock absorbers provide a quick method of fine-tuning and compression damping. By turning this screw on the bottom of the shock clockwise, the compression of the shock is increased. Turning the screw counterclockwise will decrease the compression, which will soften the ride. Just 1/4 to 1/2 turn can make a noticeable difference in damping, so make changes in small increments. The screw is effective up to 3 turns out from lightly seated. On Fox shocks, both the compression and rebound valving can be changed for high and low speed damping characteristics. Refer to the Master Repair Manual for valving options. The primary function of the rear suspension is to provide a comfortable ride in any condition. Make sure the machine has been ridden for at least 100 miles or so before making any adjustments. Whenever adjusting any feature on the snowmobile, always make sure to adjust both sides evenly. There are many adjustments that affect weight transfer. Weight transfer is the shift of weight from the skis to the track. As engine torque is applied to the drive axle, torque is transferred to the track, pulling the sled forward. The front torque arm reacts to this force by pushing down on the front of the track, in effect applying more weight to the track and reducing the weight on the skis. The rate of torsion springs are controlled by several things: the free opening angle, the installed opening angle, the diameter, the number of coils, and the length of the legs. Torsion spring preload is adjusted by turning the cam on the short leg of the spring with the engine spark plug tool. For ease of adjustment, release the long leg of the spring. Softer tension will require the longer side of the cam facing the spring. Firm tension will require the shorter leg of the cam facing the spring. Be careful when replacing the spring leg back into the guide to ensure its proper position. Optional springs are available for rider preference. The Xtra 10 is equipped with a front limiter strap that controls the amount of weight transfer and ski pressure. Lengthening the strap decreases ski pressure. Shortening the strap limits front suspension travel, increasing ski pressure. The rear limiter strap on the Xtra 10 controls ride height and increases preload on the rear springs when tightened, which also decreases weight transfer. The Xtra 12 has only front limiter straps, which have an effect on ride height and not on weight transfer. The length of the straps can be changed, but it is recommended to first turn the front scissor stops to a lower position, move it to the forward hole, or to adjust the IFS preload. Whenever making a change to the limiter strap, make sure to set each strap evenly to avoid improper Hifax wear. As we discussed earlier, the adjustments of the suspension requires a compromise. This compromise also includes the adjustment of the scissor stops. As the name implies, scissor stops limit the amount of scissor arm movement in the forward and rearward direction. This refers to the coupling action between the front and rear torque arms. Both front and rear scissor stops on the Xtra 10 and the front scissor stop on the Xtra 12 can be quickly adjusted to high, medium, or low positions using the scissor stop wrench, part number 2872012. This dot, which is placed on the longest end of the adjustable stop, allows you to see what the current setting is. A high setting stops the scissor arm quickly, while low settings allow for more movement of the arm. For example, on a front scissor stop, the high position is with the dot facing rearward toward the arm. On a rear scissor stop, the dot is facing forward for high position. The higher the setting, the less independent movement between the two torque arms. The rear scissor stop couples the movement of the rear torque arm to the front torque arm. When landing on the rear of the suspension, the rear torque arm compresses. The rear scissor stop links the movement to the front torque arm, borrowing shock damping and spring rate. This will reduce the possibility of the snowmobile bottoming. The front scissor stop couples the movement of the front torque arm to the rear torque arm. For example, when hitting a bump, the front torque arm begins to compress. The front scissor links that movement to the rear torque arm, causing it to compress, raising the rear of the rail, preparing it for the bump. The Xtra 12 rear scissor cannot be adjusted but can be changed for desired weight transfer depending on rider preference. In addition to the scissor stop adjustments, there are optional mounting positions for some models. For increased ski pressure under steady throttle or on deceleration, set the front scissor stop on the Xtra 12 in the low position. If more ski pressure is desired, move the front scissor stop by removing the attaching bolt and relocating it to the forward hole. Reinstall bolts and tighten. For the Xtra 12, if the rear suspension bottoms, increase compression valving by turning the damping screw clockwise. Increase torsion spring preload. Set the front scissor stop to high. Increase front track shock preload. On models with 133-inch tracks, replace front track shock spring with overload kit part number 287-1439. If the ride is too stiff, decrease compression damping, decrease spring preload, remove the rear track shock spring or change the rate of the spring. On models with 121-inch tracks, set the front scissor stop to low. If the machine darts from side to side, inspect the skis, spindles, and scags for proper alignment. And on models with 121-inch tracks, set the front scissor stop to high or move it to the rear hole. To set up for deep snow, set front scissor stop to low. Decrease the front track shock preload. Tighten limiter straps. On models with 121-inch tracks, set the front scissor stop to low or move it to the front hole. On Xtra 10 models, if the rear suspension bottoms too easily, increase torsion spring preload, increase rear shock compression valving. If equipped with Fox shocks, change to heavier valving. If the ride's too stiff in the rear, check for proper track tension. Decrease torsion spring preload. Decrease rear shock compression valving. If equipped with Fox shocks, change to lighter valving. If the machine darts from side to side, inspect the skis, spindles, and scags for proper alignment. Inspect and replace Hifax if worn. Reduce ski pressure by reducing IFS preload, torsion spring preload, or increase front track shock spring preload. To set up for deep snow, replace worn Hifax, set the front scissor stop too low, or move it to the forward hole. On some models, move the front track shock assembly to the upper position.